Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Zakwan bin Hamzah. My supervisor is Encik Khairul Azmi bin Bahrain. My title is IoT Device for Power Output Profile Monitoring System. Here I attach my contact that included email and phone number. If anything, just let me know. Overview of this project is concentrated on the system engineering of solar power surveillance system, which set up to track and read the power obtained from PV panels. Second, it pointing out the efficiency for the system. The ammeter and the voltmeter are attached to the solar PV panel. The data will display the current and voltage, also in power, using the current sensor straight the Arduino microcontroller. Problem statement of this project is, firstly, its incomplete interface, which is system, in terms of monitoring and real-time rate and consumption of the stored energy. Second, user requests easier way for them to monitor or control any system when they were in either place far from the system. Third, the non-dispatch, intermittent and unpredictable nature of PV panel energy. Objective of this project is to build a hardware prototype solar energy monitoring system that capable of measuring voltage, current and power output. Second, to examine the impact of sunlight, strength solar radiance on generating power. Scope for this project is focused on tracking the use of energy from the solar to the production. Second, the simulation of the performance of the system is conducted by using Arduino IDE, Proteus and freezing software. Arduino IDE is about the programming that can be connect to the Arduino. Basically, Arduino that I use is Arduino Nano, and to link the sensor, which is current sensor, and we set that OLED display and micro SD card module. Arduino IDE is the main role to connect all in one. Proteus is a medium that simulate all the programming, all the connection to make easier. The advantage of this Proteus is it can reduce the cost and the simulation will be in real time. Freezing software is about a connection diagram between Arduino and other part of the module, which is sensor module, OLED display and micro SD card module. Next, the results are evaluated in real-time basis where the energy stored is monitored. My project is the data that measured by the Arduino, which is evaluated by the sensor module, are stored in micro SD card module and can be monitored by using OLED display, and the result can be analyzed by the stored energy. Next, methodology. Methodology of this part is based from problem statement. The problem statement was elaborate from the previous slide. After I conclude all the problem statement based on the other paper, I go straight to the literature review. literature review like Elsevier, IEEE, etc. I was combine all information and gain the knowledge, the data, and so on to set up the apparatus. If apparatus was not satisfied, I gain the information it again based on the literature review or other paper. And then, if satisfied, I start to measure data. Compare with the other meter like multimeter, voltmeter, current meter. After it's satisfied, the real time data will be recorded based on voltage, current, power, and is satisfied. The data can be collected. If no, it will turn it back to measure data and counter it with the other part of measurement. And then, if yes, we'll go to collect the data. And after it collect, the result will be analysis and the report will be start right. So this is the result that what I get. However, the PV panel that I use is 5 watt, with IPM is 0.28 ampere and VPM is 17 volt. So the load that I use is also 5 watt, and then the voltage is 12 volt. Next, if you can see, is the voltage is around 11 to 12 volt. And then when you can see the curve that goes to 0 is because it's already from evening to the night, and it goes up to 11 volt in the morning around 9 to 11, and which come to the peak value of voltage in 12 or 11 am. Next, the current state just same with the voltage. As you can see, the current can be maximum to 0.25 ampere because the PV panel can exceed to 0.25 ampere only. Then also the power, which can conclude up to 3.6 watt, and the average is around 3.2 watt. This is the curve, which consists of 3 parts. It has voltage, current, and power. The upper one is the voltage, the middle one is the power, and the below is for current. Here, the data that I get from the micro SD card. As you can see, the voltage is 11.6. The voltage is start from 11.76. That means I start the measurement from 11 am, and the current is 284.21. The state is 284.21 is for milliampere. So I convert it to the lower one is 0.28421 ampere, and get the power is below around 3.34, and time is 228. The time is will be in millisecond. This is data that I get from the micro SD card module that already saved from sensor module and display it with OLED display and turn it back to Arduino Nano to save in a SD card module. So, for the lastly, future work and recommendation, firstly, implement the IoT that can control by using internet or cloud, which is over current protection, control system, daily energy measurement, and system precaution like warning notification to prevent any problem. Second, improve the range of measurement that can over to 5 ampere, 50 ampere or more than can be used in industrial. Third, improve the optional data storage device which is stored in internet or cloud that can monitor and save data 24 hours. My project can only store the data in micro SD card. If it can be improved that save in internet or cloud, so the data that saved in micro SD card can compare with the data that's stored in the internet. So it can be the advantage of the project. Next, this is my reference and then thank you. That's all.